In this lesson, we're going to talk about the volume formula for three of our final three-dimensional shapes, pyramids, cones, and spheres. So we're going to start by defining what's called the slant height. And this comes into play for cones and pyramids. And the slant height is the distance measured along a lateral face from the base of the vertex, or from the base to the vertex of a pyramid or cone. So it's the side length from top to bottom. And in the case of a pyramid, the slant height is the height of the lateral face, the triangular lateral face. So if I'm trying to do a surface area problem, you need the slant height to calculate the area of the lateral faces in a pyramid. For a cone, what typically happens is you're given the slant height and the radius, and you need to find the height of the cone, because you need the height of the cone to calculate the volume of the cone. So for example, let's say I have a cone, and I draw these things terribly, but let's say we have a cone with a slant height of 10, and that cone has a radius of 6. Well, you can create a right triangle with the slant height and the radius and the height of the cone. So the radius is 6. Here's the slant height. That's 10. If you want to find the height of the cone, you're going to have to use Pythagorean theorem. H squared plus 6 squared is 10 squared. This happens to be a Pythagorean triple. So you're going to get a whole number answer. H squared is 64, and in this case the height ends up being 8. You have to use this height to calculate the volume of a cone. So we're going to start looking at these volume formulas. The first one we're going to look at is the volume for the pyramid. And the pyramid, if you look at this, the volume is equal to 1/3 the base area times the height. So if you think of a rectangular prism, the volume of or of any prism is the base area times the height. And for a pyramid, it's basically saying that 3 pyramids would fit in a rectangular prism having the same base area and height. So the volume of a pyramid is 1/3 that. So the first example is a direct calculation. We have the dimensions of the base and we have the height. So we know that volume is going to be 1/3 the base area times the height. Let me do a units check first. Everything is in centimeters, so my units are good. I got to find the base area, which is just going to be the 9.5 times 8. So the base area ends up being 76 square centimeters. And then to calculate the volume, it's just 1/3 times 76 times the height of 9 centimeters. And that ends up being a whole number. The volume of the pyramid is 228 cubic centimeters. So you basically find the volume of the corresponding prism and you divide it by 3 to get the pyramid. Okay, the next example takes a little bit more work, and it relies on us understanding and remembering the properties of an equilateral triangle. So I have a regular pyramid and it has a triangular base. I'm not going to be able to draw that, but I am going to draw the base, because the base of this guy is an equilateral triangle, so all sides measure 4. And the volume of this pyramid is 64 radical 3 feet squared. So we do a units check first. This is in feet, this is in cubic feet, or feet cubed. This is in cubic feet, so our units are good. We need to find the height of the pyramid. Again, our formula for volume is 1/3 the base area times the height. This time I'm going to solve for the height, so I've got to find the base area first. I don't have all the dimensions I need. I have the base is 4, the little b, but I need the height of the equilateral triangle, the altitude. So I'm going to call that x. If you remember, this actually creates one of our special triangles. If I drop an altitude in here, what that does to the base is cut it in half, and I can use Pythagorean theorem. If you don't remember the pattern, I can use Pythagorean theorem to find the altitude. So if this is 4, our bottom side in the right triangle is 2, and the other side is going to end up being 2 radical 3, but just to show you, it's 2 squared plus x squared is 4 squared. 4 plus x squared is 16. x squared is 12, so x is radical 12, which ends up being 2 radical 3. So the altitude of the base is 2 radical 3. Now that I have those two dimensions, I can find the base area. The base area is 1/2 times 4 times 2 radical 3. This ends up being 4 radical 3. We're going to leave our answer like that. We leave our answer exact in radical form until the very end. Because if you see up here, the volume is also left in radical form. So I think those radical 3's are going to divide away. Putting everything together, I know my volume is 64 radical 3, and that's equal to 1/3 times the base area times the height, which is what we're looking for. Well, I can do this in a couple of steps. I can get rid of the 1/3 first by multiplying each side by the reciprocal. So that would be 3 over 1 and 3 over 1. And that's going to get me 192 radical 3. 192 radical 3 is equal to 4 radical 3 times h. To solve for h, I just divide both sides by 4 radical 3, and my radical 3's will reduce down to 1. And my height, actually 4 divides evenly into 192. My height ends up being 48 feet. So that took a few more steps. Again, you had to remember that if you have an equilateral triangle, you have to drop an altitude, which cuts the bottom in half as far as getting the right triangle to use Pythagorean theorem. But after that, it's just working through the formulas again, finding the base area, putting that into the volume formula, and then solving for the height. Our next shape is a cone, and a cone has a circular cone. So a circular cone has a circle as a base, and then we have a height. Now it's not necessary that the vertex be centered over the center of the circle. If you see down here in this diagram, it really doesn't matter. The formula is the same. It's still 1/3 times the base area times the height. Again, capital B is the base area, h is the height of the cone. It doesn't have to be a right circular cone. The formula still applies. Okay, so the first one, we're going to find the volume of this cone, and we're going to round to 1/10. Okay, let's check our units. The radius is 3.2 meters, the height is 5.8 meters, so my units are fine. If I find the base area, that's going to be pi times 3.2 squared, because remember the base area here for a cone is going to be pi r squared if it's circular. And I'm going to leave things in terms of pi until the very end. So this ends up being 10.24 pi. And now just to find the volume, we substitute everything in. It's 1/3 times 10.24 pi times the height, which is 5.8. And then we put everything in our calculator and we multiply through by pi, and we end up with 62.2 cubic meters. So that is a direct calculation problem. The next one is going to be a little more complicated, but we just think it through, and it's really not that bad. So here it is. If a cone and cylinder have the same volume and the same height, and the cone has a radius of 9 millimeters, find the radius of the cylinder in simplest radical form. Okay, so I'm looking for the radius of the cylinder. So they have the same volume and the same height. That tells me if I calculate the volume of the cone, I can set it equal to the volume formula of the cylinder and be able to solve for the radius. So the volume of a cone is 1/3 the base area times the height. I don't have the height, but I'm going to start working through this problem using what I do have. So this is going to be 1/3 the base area. I only have one dimension, and it's a radius of 9 millimeters, so that's pi times 9 squared times the height. So the volume of the cone ends up being, I'm going to leave it in terms of pi, 27 pi h. So I know the volume of the cone is equal to the volume of the cylinder. So the volume of the cylinder is going to be the base area of the cylinder times the height. I'm going to assume it's a circular cylinder because I'm looking for the radius, so that's going to be pi r squared h. I'll call that r of the cylinder because it's different than the radius of the cone. So all I have to do is take this value for volume and put it on this side. And when I do that, you'll see some things divide away. So I don't need every piece of information. My heights are going to divide away, and the pi is going to divide away. So if I divide both sides by pi h, I am left with 27 is equal to r squared. And this is the radius of the cylinder. So I'm going to move up here. So my radius ends up being radical 27. In simplest radical form, that's radical 9, radical 3, so it ends up being 3 radical 3. And that's also going to be millimeters because my other dimension was in millimeters. So you don't have to know everything. Just start out and set up your equation with what you do know and then see what you can set it equal to, because quite often things will divide away that you don't need, like the heights and actually pi as well. Alright, for the next example, if the slant height of a cone is 26 and the radius of the base is 10, we want to find the volume of the cone. So this is almost a direct calculation. You know the volume of the cone is going to be 1/3 the base area times the height. However, I don't have the height of the cone. I have the slant height. So, and I have the radius. So the slant height of the cone is 26 and the radius is 10. I'm going to create a right triangle. The bottom side is 10, the hypotenuse is 26, and we're going to solve for the height. H squared plus 10 squared is equal to 26 squared. And you end up with h squared. When you subtract 100 from the 26 squared, you get 576. That happens to be a perfect square, and your height ends up being 24. So now I can directly calculate the volume. 1/3 times the base area is going to be pi times the radius squared times 24. This ends up being, I'm going to round to the nearest tenth, this volume ends up being 2513.3. There are no units, you could say cubic units. So in that problem we ended up with a direct calculation, but we had to find the height first. And you find the height using Pythagorean theorem if you're given the slant height. Finally, we have the volume of a sphere. And a sphere is a ball, so it's a three-dimensional shape. It has a cross-section of a circle in it, and it can be defined solely by its radius. Now the volume for the sphere is 4/3 pi r cubed, where r is the length of the radius. So we'll end with this example, then we'll do the one with the ice cream cone in class. This one is a direct calculation. Snow globes consist of a glass sphere that's filled with liquid and other contents. If the inside radius is 3 inches, find the approximate volume of the material in cubic inches that can fit inside. We're going to round to like the nearest whole number because it's just the approximate volume. This is a direct calculation. The volume is equal to 4/3 pi r cubed. So this is a direct substituted in, calculate an answer. My radius is 3 and I cube it, and when I put all that in my calculator I have 36 pi, and then if I want to find the approximate volume I multiply through and I get the volume is approximately 113 cubic inches. Okay, and the last example is going to be an ice cream cone example that we will do together in class. So this is a brief introduction of the 3 volume formulas, pyramids, cones, and spheres.